often depends on how much time has passed. Unless you stop feeding and watering it and then it dies, but still. Time is the most common independent variable. Sometimes, though, you can pick. If time isn't part of your experiment or your graph, you get to pick. A function, its definition is you only get one dependent variable for each independent variable. Okay? For example, of a function. When we're going to get to this later in the year, but I'll give you a little preview. Y equals negative x squared. Nope, I'm not going to use negative x squared. I'm going to use negative
3.
Now, do I want to do metric or not? Negative 16 x squared plus 50. Now, you don't need to know exactly what this looks like. But I'm going to go ahead and tell you, if you look at this function in quadrant 1. Remember what quadrant 1 means?
Yeah.
It's the part of the Cartesian coordinate plane where everything is positive. Okay, where the x's and y's are both positive. Then it goes 2 over here.
Which is negative.
Over here is where y is still positive, but x is negative. Down here in 3, x and y are both negative. And over here in 4, x is positive, y is negative.
So there's only one positive quadrant?
One quadrant where everything's positive, yes.
Oh.
Okay? Now, negative 16 squared plus 50, I'll go ahead and just tell you, looks something like this. You don't have to label it exactly. And this is a graph that we use. This will tell you roughly how high an object is if it falls from a height of 50 feet. Okay, this actually has a real use. Okay, something falls off a ledge 50 feet high, or something jumps off or is pushed off, it's a diver maybe, and you want to time how high it is at different times. A second after it jumps, this is going to sound really obvious. This question is really obvious. It's not meant to be a trick question. Guy jumps off a ledge. 1 second later, how many different places is he in? One. He's only in one spot. That's what a function is set up to describe. 1 second after he jumps, he's just here.
So you're saying a function's only one?
A function is only one y value for each x. Okay? It's only one y value for each x. And it was set up to behave that way because if you're conducting an experiment, you're watching something fall, for example, you only expect to see it in one spot 1 second after it falls. 2 seconds later, it's going to be a different spot, but only one. Reason for that is it's easy to make graphs that don't follow that rule. Okay? For example, I can graph x equals y squared. There's no reason I can't graph that.
But it's only one. Goes straight through, right?
Well, this behaves a little differently. We'll get into this a little bit later. Probably not until spring. With the inverse functions. This happens to look something like this.
That's a parabola.
It is a parabola, but it's a sideways one. Now, mathematically, there's nothing wrong with this. Okay? But thanks to Renee, for almost 400 years, our brains have been trained to think horizontal is the time axis. If I conduct a really simple physics experiment, I throw a football or something, 10 seconds after I throw it, would it make sense for the football to be up here and below the ground simultaneously?
No.
No. So that's not a function. Okay? That's what functions were designed to do, to give only one occurrence of the dependent variable at each occurrence of the independent variable. That sort of makes sense? Okay. This is not a function. There's a very simple test for this. Okay? The test is called the vertical line test. The memories are slowly coming back for Sarah. The vertical line test. Okay? If you can draw a vertical line, vertical's up and down, by the way. Horizontal, vertical. I mix those up sometimes.
You can remember the horizon. Yeah.
The horizon, horizontal. Honestly, I have to do that every time. If you can imagine a vertical line anywhere along the x-axis, if that line hits a graph twice or more,
Then it doesn't work.
then it fails the vertical line test. The vertical line test is that a vertical line anywhere you can imagine will only hit a function once. My parabola over here, if I imagine vertical lines going through it, a vertical line, anywhere I put it, will only hit this function once. That's because above or below each x, it only has one value. Yes?
So that's not a function?
Yes. X equals y squared, not a function. It's a fine equation. It's a lovely graph. Mathematically, there's nothing wrong with it. There's even uses for it. But mainly in high school, you study functions. Mostly. We'll do a couple of non-functions this year. Yes?
What does that say after you can?
A vertical line anywhere you can imagine will only hit a function once. You guys are seeing today why I like it better when I type.
Well, why can't you type right now?
Yeah. Well, I'd be running back and forth. This stuff is just, I didn't think I could draw it fast enough. Plus this last part, I don't really know how to graph.
It's not, does this say hit?
Yes. Hit. Okay. Now, your book has yet another way to explain this. Okay? Another definition of a function.
So this is a confusing one, then not.
Actually, most people I thought the dependent-independent variable one would be the confusing one. But you guys handled that beautifully, I think. Unless I'm totally misreading you. Unless you guys are very good at faking comprehension. Okay, another definition of a function is only one output
That's the one I know.
for each input. Well, you should have said that first there.
I didn't remember the name.
All right.
Just I'll put an input and it remembers the box that
Right.
when my last year's teacher did.
Only one output for each input, and y is the output. That's the dependent variable. X is the input. That's your independent variable. Most often time, but it can be other things. Okay? And y is your output, x is your input, and you get only one output for each input. That's a function. Your book will also deal with some stuff where you just have data. Okay? For example, hey, is this Bobby's?
Yeah, did you
Yes.
grade it?
Yeah, I will. Thanks. Okay. Only one output for each input. So example. Given a relationship between data points. If what you're given is a relationship between some points of data. Okay, sometimes this will usually be coordinate points. Or what else does your book do with this? Input versus output? A little bit. Okay. Is the following a function? And most of the examples I've given so far have been graphs. But let's take a look at this. This won't be like an equation like y equals something. Okay?
Well, aren't you giving us two functions? Aren't they like with the y and x and speed?
Oh, we're giving you a bunch of points. It's even weirder. You have points. I'm just going to give you the points